Okay, so now we have a couple more exercises here, so let's see what we can find over here. Find a couple of exercises. So for example, let's say that you have some polynomial and you want to know as a factor which of the following is the factor. So for example, you have this polynomial over here, x cubed plus x squared plus x cubed plus x squared plus x plus 1, and you want to know whether this polynomial has x plus 1 as a factor, meaning that if x plus 1 is a factor of this polynomial. So the way that you can decide that is that the root of basically the root of this x plus 1 is equal to 0. The root of this polynomial equation is equal to x is equal to negative 1. So you can take negative 1 as your a, and now if I take this for example as p of x, if p of negative 1 is equal to 0, if that's true, then that means that basically that means that p of x is a multiple of x plus 1, or x plus 1 is a factor of p of x. So then I can calculate p of negative 1 over here, which is equal to negative 1 whole cube plus negative 1 whole squared plus negative 1 plus 1. Okay, so this is equal to negative 1 plus 1 plus negative 1 plus 1. So these two will cancel out, these two will cancel out, and you'll end with 0. That means that p of negative 1 is equal to 0, and what that means is that x plus 1 is a factor of p of x. Or as another example of the same type, so let's say that for example you have x raised to the power 4 plus 3x cubed plus 3x squared, for example, plus x plus 1, and you want to know whether x plus 1 is a factor of this polynomial p of x, for example. So again, your a here is negative 1, so then if I calculate p of negative 1 here, p of negative 1 would be equal to negative 1 raised to the power 4 plus 3 times negative 1 whole cube plus 3 times negative 1 whole squared plus negative 1 plus 1. That's equal to 1 minus negative 1 whole cube is equal to negative 1 times 3 is equal to negative 3. Negative 1 squared is equal to positive 1, that's positive 3, plus negative 1 plus 1, and that these two will cancel out. These two will cancel out, and the answer is 1. So that means that, so the remainder, basically p of negative 1 is equal to 1. That means that if you divide this polynomial by this polynomial, the remainder is going to be equal to 1. And so what that means is that this polynomial is actually not divisible by this polynomial. And so another way of saying that is that x plus 1 is not a factor of p of x, basically. Okay. Now, the next question that we have, let's see, the factor appearance of the following. So you want to use the factor theorem in order to decide, for example, let's say that you have p of x is equal to 2x cubed plus x squared minus 2x minus 1, and g of x, for example, g of x is equal to x plus 1, and you want to know if g of x is a factor of p of x. Again, you can do the same thing, meaning that you can basically set this x plus 1 equal to 0, and then x would be equal to negative 1. So now if the value of this polynomial at this value is equal to 0, that means that this polynomial is actually divisible by this polynomial. So p of negative 1 here is equal to 2 times negative 1 whole cube plus negative 1 whole squared minus 2 times negative 1 minus 1, which is equal to negative 2 plus 1 plus 2 minus 1, and these two will cancel out and you'll end up with 0. That means that this polynomial is actually divisible by this polynomial, or this polynomial is a factor of this polynomial. So now these are the kinds of things that we already know how to do, so let's move on to some, for example, to some factorization. So let's say that you want to factorize to, for example, 12x squared minus 7x plus 1 minus 7x plus 1. So in order to do that, you're actually looking for two numbers, a and b, such that a times b is equal to 12 times 1, which is equal to 12, and a plus b is equal to negative 7. So you can go for 3 and 4, and take them as negative 3 and negative 4. Now negative 3 plus negative 4 is equal to negative 7, and negative 3 times negative 4 is equal to positive 12. So I can rewrite this as 12x squared minus 3x minus 4x minus 3x minus 4x minus 7x plus 1. And then I can take, for example, these two together and take a 3x out and 4x minus 1, and take a negative 1 out here, and that would be 4x minus 1, and then that would be 4x minus 1 times 3x minus 1. That would be the factorized version of this polynomial. Or if you have something like 2x squared plus 7x plus 3, you have 2x squared plus 7x plus 3. Again, you're looking for two numbers a and b such that a times b is equal to 2 times 3, which is equal to 6, and a plus b is equal to positive 7. So 1 and 6, and 1 times 6 is equal to 6, 1 plus 6 is equal to 7. So I write this as 2x squared plus x plus 6x plus 3, and I can take these two together and take an x out. That would be 2x plus 1. Take a 3 out, 2x plus 1, and x plus 3 times 2x plus 1. And that's the factorized version of this polynomial. If you have, for example, 6x squared plus 5x minus 6, you're looking for two numbers a and b such that a times b is equal to 6 times negative 6, which is equal to negative 36, and a plus b is equal to positive 5. So that's 12 and So 36 is equal to 2 times 18. One of them is negative, right? One of them is negative. 2 times 9, 4 and 9. So you can go for 4 and 9. 4 times 9 is equal to 36. And you can take them as 9 and minus 4. 9 minus 4 is equal to 5. And 9 times negative 4 is equal to negative 36. So it's 9 and negative 4, for example. So then you can write this as 6x squared plus 9x minus 4x minus 6. And then you can take these two together. Take a 6 out, for example. X squared minus 1. Take these two together. No, that's not possible. That's not possible. You can take these two together. 4 and 6. These two together. And these two you can take together. Take a 3x out. So that's 2x plus 3. And here take a negative 2 out. That would be 3x. I'm sorry, 2x plus 3. And that's equal to 3x minus 2 times. I'm sorry. Okay, 3x minus 2 times 2x plus 3. That's the factorized version of this polynomial. The next thing that we have here is, let's say that you have something like 3x squared minus x minus 4. Let's say you have 3x squared minus x minus 4. So here again you're looking for two numbers a and b such that a times b is equal to negative 12, 3 times negative 4, and a plus b is equal to negative 1. So you can go for 4 and 3, and negative 1 would be negative 4 times negative 4 plus 3 is equal to negative 1, negative 4 times negative 4 plus negative 4 times 3 is equal to negative 12. Okay, so 3x squared minus 4x plus 3x minus 4, and then you can take these two together and take a 3x out, x plus 1, and here take a negative 4 out, x plus 1, and then that is 3x minus 4 times x plus 1. Okay, so that is that. Now let's factorize a few a few polynomials of a few cubic polynomials. Okay, so now let's factorize a couple of these cubic polynomials. So let's say that you have x let's say that you have x cubed minus 2x squared minus x plus 2, and you want to factorize this polynomial. So the way to factorize this polynomial is so first you need to reduce it to somehow to a second degree polynomial, and the only way to do that is by using the factor theorem. So basically the constant term over here, which is a 2, is basically always the product of the three factors of this polynomial. I'm sorry, the product of the three zeros of this polynomial. meaning that if you take your zeros as A, B, and C being the zeros of let's say P of X, okay, then A times B times C is going to be equal to actually negative I mean the negative A times B times C is equal to this constant over here, which is equal to 2. That means that ABC is equal to negative 2. So now if you factorize 2, basically you will have 1 and 2, and since your number is a negative number, it could be a negative number. It is of course a negative number times a positive number. So I could have, I mean, the possible values, the different possibilities for A, B, and C are equal to basically plus or minus 1 and plus or minus 2. So now I want to find out which one of these is going to be a factor, is going to be a 0 over here. So now if I calculate, for example, P of positive 1, and if it gives me a 0, that means that this is a 0 of this polynomial. Meaning that if P of 1 gives me a 0, that means that the remainder, what that means is that if I divide P of X by some polynomial by some first degree polynomial whose let's say that you have a polynomial, for example, X. Let's say that one of your zeros is, for example, A, right? Is one of the zeros of, for example, P of X. If that's the case, then if A is one of the zeros of P of X, then X minus A is going to be one of the factors of P of X. And so now this factor over here, okay, so since this is a factor of P of X, that means that if I divide P of X by that factor X minus A, that's going to give me some quotient, for example Q of X, plus a remainder 0 being the remainder. Okay, so what that means is that now when I calculate P of A over here, the whatever that happens to be, that's going to be this remainder over here. So now if this remainder is equal to 0, what that means is that basically this is a factor of P of X. And so if this is a factor of P of X, then A is going to be one of the zeros of P of X. That's basically how the whole thing fits together. So then what I'm going to do is that I'm going to basically calculate, for example, for example, start with any of these numbers. For example, positive 1, negative 1, positive 2, and negative 2. So, for example, P of 1 is going to be equal to here 1 cubed minus 2 times 1 squared minus 1 plus a 2, and that's equal to 1, and that's equal to minus 2 minus 1 plus 2, and these two will cancel out, and that's equal to 0. So P of 1 is equal to 0, that means that 1 is a 0 of p of x. 1 is a 0 of p of x. Okay, and now since 1 is a 0 of p of x, that means that x minus 1, and so what that means is that, so since 1 is a 0 of p of x, then x minus 1 is a factor of p of x, and so what that means is that you can write p of x as this factor x minus 1 times some polynomial g of x, for basically g being g of x being some polynomial. Okay, so then so now you need to figure out what your g of x is. Okay, so now g of x here, this polynomial, is equal to p of x divided by x minus 1. So now if I take p of x and divide by x minus 1, that's going to give me g of x. So p of x over here was equal p of x over here was equal to this polynomial here, x cubed minus 2x squared minus x plus 2, and I want to divide it by x minus 1. So you have x cubed minus 2x squared minus x plus 2, and I want to divide it by x minus 1. And sometimes you can actually do a couple of things, and sometimes without basically long division you can actually get to the answer, but basically if you do the long division, then you don't have to think unnecessarily. So then x cubed divided by x is equal to x squared. So x squared times x is equal to x cubed, and that's minus x squared, negative positive, and so these two are going to cancel out. And what this gives you is negative 2x squared plus x squared, which is equal to negative x squared, and you have a negative x over here. So then negative x squared divided by x is equal to negative x. So negative x times x is equal to negative x squared, and negative x times negative 1 is positive x. Now this is positive, negative, and if you add them together, you'll get negative 2x plus 2. Okay, and then negative 2x divided by x is equal to negative 2. So negative 2x plus 2, and then if you add these, you will get positive, negative, and then these will cancel out, and you have a 0 remainder here. So basically g of x is equal to p of x divided by x minus 1, which is the same thing as x cubed minus 2x squared minus x plus 2 divided by x minus 1, which is equal to this quotient over here, which is x squared x squared minus x minus 2. Okay, so far we got this reduced to a second degree polynomial. So what this now means is that basically this was p of x. So now I can write p of x as a product of basically I can write p of x now as a product of this polynomial and this polynomial. So x squared minus x minus 2 times x minus 1. Now you can basically factorize this polynomial using by basically splitting the middle term, and then the whole thing is basically that way done. So if you have x squared minus x minus 2, so you're basically looking for two numbers, for example a and b, such that a times b is equal to negative 2 and a plus b is equal to negative 1. So that's basically 1 and 2, and the product of these two numbers is a negative number, so one of them is negative and the sum of them is negative. So so then if you take them as positive 1 and negative 2, 1 times negative 2 is equal to negative 2, and negative 2 plus 1 is equal to negative 1. So the numbers are 1 and negative 2. So I rewrite this as x squared minus 2x plus x minus 2, and then this is going to give me x times, for example, if you take these two together, x times x minus 2 plus 1 times x minus 2, and so that's x minus x plus x minus 2, x minus 2 times x plus 1. Okay, so now I can rewrite this polynomial as x minus 2 times x plus 1 times x minus 1, and that's basically your p of x, which is basically equal to x cubed minus 2x squared minus x plus 2. That's basically what you were looking for. Okay, so that's basically the whole story there. Next, let's do another one of these. Okay, so let's do one more of these cubic polynomials. X cubed minus 3x squared minus 9x minus 5, and let's call this, for example, p of x, and you want to basically factorize this polynomial. So again, the last term over here, which is negative 5, if you think of the zeros of, if a, b, and c are the zeros of p of x, then a times b times c, actually negative a times b times c, is equal to negative 5. So that means that ABC is actually equal to 5. Okay, so that means that basically if you factorize 5, you will get 5 is equal to 1 times 5. So the only two factors that you get are 5. So the different possibilities for either a or b or c is basically plus or minus 1 and plus or minus 5. So let me see, I have to do. Okay, so the different possibilities for the zeros are basically plus or minus 1 and plus or minus 5. So let's test to see which one of these is basically the zeros of one of the zeros of this polynomial. So again, if any of them is a zero of this polynomial, then p of that number is supposed to be equal to 0. And hopefully by now you know why I say this, because I don't want to repeat myself anymore. So for example, if I go for p of positive 1, that's equal to 1 cubed minus 3 times 1 squared minus 9 times 1 minus 5, which is equal to 1. So that's 1, so that's negative 3 minus 9 minus 5, and that's not going to be equal to 0. So this is 14, 17, negative 16 or so. So P of negative 1 is equal to negative 1 whole cube minus 3 times negative 1 squared minus 9 times negative 1 minus 5, and that's equal to negative 1, and this is negative 3, this is positive 9, negative 5, and that's equal to negative 8, negative 9 plus 9 is equal to 0. So negative 1 is one of the zeros of this polynomial. Okay, so what that means is that if 1 is a zero of P of x, then as a result of that, x plus 1, or basically x minus 1, which is the same thing as x plus 1, is going to be equal to a factor of P of x. And the reason why I write it as x minus negative 1 is that basically when I then if I set this to 0, x minus negative 1 is equal to 0, then basically x plus 1 is equal to 0, and then x is equal to negative 1. And then this number is actually equal to the 0 that I got over here. So that's basically why I write it that way. So now, since I know that x plus 1 is a factor of P of x, so that means that P of x has to be divisible by x plus 1. Okay? So therefore, P of x is going to be equal to x plus 1 times some polynomial, for example, g of x. For some polynomial g of x. For some polynomial g of x. And so in order to find out what g of x is equal to P of x over x plus 1, which is equal to x cubed minus 3x squared minus 9x minus 5 over x plus 1. And if you do this division over here, x cubed minus 3x squared minus 9x minus 5 divided by x plus 1, what you will get is here x cubed divided by x is equal to x squared, so that's x cubed plus x squared, negative, these two will cancel out, negative 3x squared, negative x squared is negative 4x squared, negative 9x, this comes down here, and then negative 4x squared divided by x is equal to negative 4x, so that's negative 4x squared, negative 4x, and then positive, add them together, we'll get negative 4x plus negative 9x plus 4x, which is equal to negative 5x minus 5, and negative 5 divided by x is equal to negative 5, so negative 5x minus 5, and then here you'll get a 0, and so this is equal to x squared minus 4x minus 5. So then what you have here is basically your polynomial written as a product of, so you can basically say that now your p of x, which is basically this polynomial here, p of x is equal to x plus 1, which is a factor, times this polynomial here, which is another factor, x squared minus 4x minus 5. And so you can factorize this polynomial as well if you were to basically x squared minus 4x minus 5. So you're looking for two numbers, for example, a and b, such that a times b is equal to 1 times negative 5, which is equal to negative 5, and a plus b is equal to negative 4. So that would be, for example, 1 and 5, and negative 5. So 1 times negative 5 is equal to negative 5. 1 minus 5 is equal to negative 4. So I write this as x squared minus 5x plus x minus 5. And I take these two together. I take an x out, so x plus 1. And I take a negative 5 out there from these two. And that would be x plus 1. So that would be x minus 5 times x plus 1. So I can write this polynomial as x minus 5 times x plus 1 times x plus 1. So then basically you can say that this polynomial over here, which is x cubed minus 3x squared minus 9x minus 5, is the same thing as x plus 1 squared times x minus 5. Okay, that's basically what you were looking for. So that is that. Let's do another one of these, and we have two more of them. These are actually the kind of things that are important, so you need to be more familiar with them. So let's say that you have x cubed plus 13x squared plus 32x plus 20. Let's call this, for example, p of x. Okay. So basically again, you know that the minus, if you take, for example, a, b, and c, being basically zeros of p of x, then you can say that a times b times c is equal to, or negative abc is equal to 20. That means that abc is equal to negative 20. So if you factorize 20, you will get basically 1 and 20, or 2 times 10, or 2 times 5. So all the different factors of 20, if you were to write all the different factors of 20, that would be 1, 2, and 5. And of course, then you can have 4, and then you can have 10, and then you can have 20, and then you can have, that's basically it. That's basically all the factors of 20. So now you can, and of course you need to go with positive and negative of all of these numbers. So positive, negative, plus or minus 1, plus or minus 2, 5, 4, 10, and 20. Okay. So you can start with, for example, 1. And one by one you need to check which one of these is a 0 of this polynomial. So for example, p of 1 is equal to 1 cubed plus 13 times 1 squared plus 32 times 1 plus 20, and that's equal to 1 plus 13 plus 32 plus 20, which is not going to be equal to 0. So this is not the one that I'm looking for. P of negative 1 is equal to negative 1 cubed plus 13 times negative 1 squared plus 32 times negative 1 plus 20, which is equal to negative 1 plus 13 minus 32 plus 20, and that's equal to 20 plus 13 is equal to 33. 33 minus 1 is equal to 32, minus 32 is equal to 0. So negative 1 is a 0. Is a 0 of P of x. Is a 0 of P of x. Negative 1 is a 0 of P of x. So since negative 1 is 0 of P of x, then x minus minus 1, which is the same thing as x plus 1, is a factor of P of x. Okay? So now what that means is that if x plus 1 is a factor of this polynomial, that means that this polynomial is divisible by x plus 1. And as a result of that, you can say that basically P of x divided by x plus 1 is going to be equal to is going to give you some quotient q of x plus some remainder 0. The remainder is 0 because x plus 1 is a factor of P of x. Or you can say that P of x is equal to x plus 1 times q of x for basically some polynomial q of x. Okay? For some polynomial q of x. Now, in order to find out what this q of x is, you can solve this equation, meaning that q of x is equal to P of x divided by x plus 1. And so P of x was equal to this polynomial here, x cubed plus 13, x squared, and so on and so forth. So I write it over here. So that's x cubed plus 13x squared plus 32x plus 20 over x plus 1. Okay? And so you can do this, divide this thing, so meaning that you can write x cubed plus 13x squared plus 32x plus 20 and divided by x plus 1. So then x cubed divided by x is equal to x squared times x is equal to x cubed plus x squared, and negative cancel out. 13x squared minus x squared is equal to 12x squared plus 32x. 12x squared divided by x is equal to 12x. So 12x squared plus 12x, and negative, so you have these two cancel out. 32x minus 12x is equal to 20x plus 20 divided by that would be 20, so 20 times x is equal to 20x plus 20, then these two will cancel out, you'll have a 0. So that means that basically this polynomial divided by this polynomial is going to give you x squared plus 12x plus 20. So that's that. And then so you can say that so this is p of x, and this is basically you have divided p of x by this polynomial, and it's giving you this polynomial. So that means that p of x is equal to x plus 1 times this polynomial, which is x squared plus 12x plus 20. And now all you need to do is just factorize this polynomial here. Is just factorize this polynomial here. So you have x squared plus 12x plus 20. We are looking for two numbers a and b such that a times b is equal to 20 and a plus b is equal to 12. So that's 10 and 2. So 10 times 2 is equal to 20, 10 plus 2 is equal to 12. So x squared plus 10x plus 2x plus 20. And you can take, for example, these two together, x times x plus 2 plus 10 times x plus 2. That is x plus 2 times x plus 10. So you can write this as x plus 1 times x plus 2 times x plus 10, and that is equal to your polynomial, your p of x, which is equal to x cubed plus 13x squared plus 32x plus 20. And that's basically the factorized version of this polynomial. But I guess it's enough for here for now. We have done enough exercises, and I guess we don't need to do more on this. The next thing that we have here, there are some algebraic identities that if it's required we will go back and do them, otherwise I don't know, you probably already know them. But if you have problems, we will actually move forward, and then we will basically find out whatever we need to do, we will do it. Okay, so that was that. So in the next video we will do some exercises related to the relationships between the zeros and the coefficients of some polynomials. So I'll see you in the next video. Thank you.